Hello friends, very good morning. And in this video, we are going to work out a problem on the section of a square pyramid. And the dimensions of the square pyramid are given as side of base 40 mm and height is 65 mm. And it is being cut by a section plane such that the true shape is a trapezium. So basically, friends, we need to know what a trapezium is. Friends, a trapezium is a figure, a quadrilateral, which has got the parallel sides equal, and the dimension of these two should be given, and the distance between these two should also be given. So he says you have got a square pyramid resting on HP, and it has not been specified how the object is being placed, but they have given this dimension as 30 and this as 20. So the true shape you get should be a trapezium having 30 and 20 as the dimensions of the parallel sides. And now, friends, is asking us to draw the true shape, the front view, sectional top view, sectional side view, and also we have been asked to draw the development of the lateral surface of the solid. Friends, basically, we need to position the object initially correctly so that all the other solution, the requirements can be met with easily. Now, friends, if you have to have a true shape, a trapezium, the two parallel sides should be at a distance. And now, if you keep the square pyramid with two sides or any one of the sides or all the sides equally inclined to VP, you are going to get the front view like this. But here, friends, if you cut it like this, you will have a point here, 2 points here, 1 point here, and that figure is going to have the shape of a distorted, what you call trapezium, distorted rhombus you will have, not trapezium. So how we should place the object is, we have to place the object on HP such that one of the sides of that is parallel to VP. So friends, say this is the top view of the square pyramid and it has to be placed with one of the sides normal to VP. The dimension of this are given as 40 mm. So this is SQ40 I will write, indicating that it is a square of 40 millimeters side. And let us mark these corners as A, B, C and D. The side CD is perpendicular to VP. Friends, after this, let us obtain the corresponding front view. So friends, very obviously in the front view, you are going to get a triangle whose base is equal to 40 and the height is given to be the 65 millimeter. It has a dimension of 65 millimeter height and the base has got a measurement of 40. So let us transfer all these points of the base to the front view. So we get here A dash, this is B dash, C dash and D dash. This line ABCD represents the base of the solid. And here, friends, we can mark it as O dash, the vertex, O1 dash as the center of the base. Very obviously, the axis of the solid is now perpendicular to HP. And friends, without fail, you have to mention here the XY line, VP and HP to indicating that we are solving this problem using first angle projection. I'll simply call this end as Y. XY is the line of intersection of VP and HP. Now friends, you got the front view and top view. Now we have to cut it by a section plane such that the true shape is going to be a trapezium having side 30 and 20. Now friends, if you have got a section plane passing through this AB, the base edge will have one of the dimensions as 40 and this will be having a dimension here, the parallel side, depending on the inclination of the section plane with the HP. So friends, what we do, here it says it has to be 30 by 20. So friends, here I am going to mark the center line and mark point O comma O1. So O comma O1 I am going to mark here, O comma O1, and here I am going to mark a distance of 30 on one side. How to mark 30? I will take 15 millimeter on each side. This is 15 and this is 15. Similarly, the parallel sides will have 10 plus 10, 20. Say I am going to have this gap as 10 comma 10. So both the sides are 10 and this is 10. So you have got these 4 points, and now friends, let us transfer that because it is cutting all the 4 slant edges. So I am going to draw a horizontal line through this. So we are going to get 4 points, one on each of these slant edges. And friends, if we extend like this, you are going to get a point here, another point here. So totally you have got 4 points and we will join them by straight line. This is how friends you are going to obtain the top view. You will section that by having lines drawn at 45 degrees to the horizontal. Now friends, we will darken this sectional top view. So all the borders to be joined by straight line. This is by straight line and all these corners are available here. We will join them by straight line. Friends, now OA is cut here. Extend that point to a point here onto the corresponding edge in the front view. So this will give you 2 points. Suppose this is 1 and 2. This is 1 comma 2. Similarly friends, if you draw a vertical line through this, it is going to cut these vertical edges or the slant edges at these 2 points. So we will call those points as 3 and 4. So there is no place to mark here. So this is 1, 2, 3, 4. So we have marked all this. Now friends, through these 4 points, we have to draw a line which represents the section plane. Yes, yes. So this is the section plane. Yes, yes. And friends, after you draw the section plane, we have to retain the lower portion of the pyramid, that is below the section plane. So I am going to show that by visible lines here, visible line and this visible line. So totally we have got 4 points on this. And now in case they ask you to find out what is the angle made by the section plane, it is very obvious, it is perpendicular to VP and you can easily measure what is the angle made by this section plane with HP. I will say theta and this theta can be found out. Friends, we have got the front view here showing the section plane. The upper part of the solid is removed and here this is the sectional top view. We call it as STV. And friends, front view sectional top view you have got. Draw the front view, sectional top view, sectional side view is being asked. How to draw the sectional side view, friends? Now, after throwing away this piece, let us see how to mark the sectional side view of it. So to start with, you will assume that the object is not cut by the section plane and hence you are going to have another square here, that is triangle, exactly similar to the front view because of symmetry. If you look from this side, you see a triangle. If you look from this side also, you see a triangle. Now friends, what I do, I am going to draw a 45-degree line here and obtain the side view. So I will just draw a horizontal line to cut here, a point here. Similarly, another horizontal line here. So you are going to have this width is equal to same 30. So this point is going to be A double dash D double dash and this is going to be B double dash C double dash we have this vertex. Draw a horizontal line exactly through the center of this. You are going to have the axis, and this can be numbered as O double dash. The bottom one is O1 double dash. Friends, we will join this to the vertex, the base points to the vertex. A thin line like this, a thin line here, and after getting the points, we will darken it or shade it. So now friends, OA and OB are cut here. Draw a horizontal line through that. So OA is cut here, OB is cut here. So we get 2 points. And you just number them as 1, 2. Then friends, we have got 3 and 4 on this edges C and D. So from here, I will draw another line parallel to XY and obtain 2 more points here. The points are 3, 4. And friends, if you join these 4 points by straight line, so these are the 4 points to be joined. You have to section it by drawing lines at 45 degrees to the horizontal. The bottom portion of the solid is to be shown by the visible lines. So I am going to show it by dark line and the dark line. So this point is O1 double dash. So friends, we have got what is called the left sectional end view or SSV, sectional side view or left sectional end view. That's how we get, friends. And after completing this, we have been asked to draw TS. TS stands for the true shape of the section. Friends, to obtain the true shape of the section, we have to draw a line parallel to the cutting plane or the section plane at any convenient distance. Say friends, I am going to draw a line here that is parallel to the section plane. And from these 2 points, I am going to draw perpendiculars to that line drawn parallel. So friends, I am going to have one line here and another line passing through this. So we have got 2 lines passing through 1, 2, 3 and 4. So friends, we will just mark that. And here friends, on these lines drawn perpendicular to this line, we have to mark the distances of points 1, 2, 3 and 4, taking one by one. So on this line, you are going to get 1 and 2. How to get it? Take the distance of this 1 from the xy, transfer this distance onto the, say you get a point here. Similarly, friends, transfer the distance of point 2, that is from 2 to xy, and that. So we'll call this point as 1, this as 2. We have got 1 and 2, then you have to get 3 and 4. 4 is nearer to xy. So friends, on this line, we are going to have 3 and 4. Say 3 will be here and 4 is nearer, 3 is away. This point is 3. They should be in order 1, 2, 3, 4. Friends, the points so obtained are to be joined by straight line. So I am going to join 1 to 2 by a straight line, then 2 to 3, 3 to 4, and all these are joined now. Friends, this figure is the true shape of this portion, that is true shape of this, or the mirror image of that. Now friends, I am going to section it by lines drawn at an angle of 45 degrees to the horizontal. And now a sort of check is to be made. That is, in the question they have given that the true shape you have will have a length of 30 mm and this is going to be 40 millimeter, sorry 20. 30 and 20 are the dimensions. And if you are asked to find out what is the distance between these two parallel sides? You can find out this distance. That will give you the distance between the parallel ends of the trapezium. I will mark here. This is the true shape and the true shape is trapezium. Trapezium with parallel sides measuring 30 and 20. So you can observe here, friend, this gap from 1 and 2 is 15 plus 15, that is 30. 30. And the gap between 3 and this is 3 and this is 4 is 10 plus 10, 20. So it is satisfying all the requirements. Now friends, after obtaining the front view, sectional top view, sectional side view, and true shape of the section, we have been asked to draw the development of the lateral surface of the lower part of the square pyramid. So now friends, we will assume that the object is not cut by any section plane. So I am going to have a line drawn here, which should be the true length of this slant edge. Say I will mark it as true length and I will show you later. So taking O as center and true length as radius, I am going to draw a sector, an arc like this. On this I am going to mark this dimension is 40, 40, 40, 40, 40. This is 40, 40, 40, and again this is 40. So we'll join all these. These are all the true lengths of the slant edges. And I will let you know how to obtain and when to obtain that. The base of the solid is intact, so we will join them by straight lines later on. Friends, here, how to obtain that true shape? You know very well, for all these developments, we make use of the true lengths and of the edges, either the slant edge or the base edges, whatever it may be. Here, none of these slant edges, OA, OB, OC, or OD, are parallel to VP, and hence none of these slant edges in the front view give you the true length of the slant edge. So, what is to be done, friends? This is a simple concept. You draw a horizontal line through the center. Now, taking the center as the center point as the center and this distance OC as the radius, you strike an arc and extend this up to the front view XY line. Then you are going to join those two to obtain the true length of the line. So using that true length PL, I have drawn this sector, and here friends you can start the development or commence the development from OA, OB, OC, whatever it may be. So I will start from OA. This is slant edge OB, OC, OD and OA again, because the last and the first should have the same numbering, they will have the same length. Now friends, OA and OB are cut at points 1 and 2, but these two lines are not true length. Hence, I am going to shift that to the true length line and take that measurement on true length and transfer that onto OA and OB. So, this is OA, this is OB, and again this is OB. OA, OB, we have transferred. Friends, 3 and 4 are cut here. Again, O dash, C dash, O dash, D dash are not true length. Hence, I transfer or shift that point to the true length line. Take this measurement on OC, OD, little higher. OC, and this is OD. Friends, you have got 4 points now. Let us number them. 1, this is 2, 0.3, this is 0.4, and then again 0.1. You got 1 and 1 on OA, on OB it is 2, 3 on OC, 4 on AD. Join all these points so obtained by straight line. So this is a straight line, again a straight line, 1 to 2 is also a straight line. Friends, the base of the solid is intact. So all the base edges of the pyramid are to be joined by visible line. This is one edge, second edge, This is the edge number 3. Finally, this is edge number 4. So I got all these, friends. Now we have to show which portion is retained. Portion from 1 to A, 2 to B is retained. So 1 to A should be shown by a dark line. 1 to A again by dark line. And here 2 to B should also be a dark line. This 2 to B is a dark line. And then 3 to C, 4 to D. So these two should also be dark line or visible line. Friends, if you call the lower portion, this portion as P, this will give you development of P, the development of the lower part of the lateral surface. Okay, friends? Now, friends, in this particular problem, we have combined two problems. One is on the section of a square pyramid, and the second part is drawing the development. So I have combined sections of the solid and development of the same in the same question. By going through this in detail, you will be able to have the solution for two problems. Instead of making two videos, I have just combined both and made as a single video, and this is going to be a very good problem in the examination, and it will help you to solve two problems on this pentagonal pyramid. Friends, hope the presentation was interesting. If you like this video, please share with all your friends without fail. Have a wonderful day.